Okay, so let's discuss a question from strength of materials. We basically have a beam and then there's an extension corner at the end and a load W is applied. So what we want is the end deflection should be 0 at B, and for that what is the ratio of L by A? Now first of all, why will the deflection be at B will be 0? Now for that we need to see what is the forces that come at B. If you take a section and balance the right hand side, just consider the right hand side, okay, the right hand side with a section here. So there is a W here, and because of this W, if you balance the right hand side of this section, there has to be W here, okay, because of the force balance, and this W at this point produces anti-clockwise couple, so there has to be a couple which balances this, and that is nothing but W into A. So these reactions is in order to balance this W, right? So now when I take the left side of this, which is AB, remember that what we are doing is we have taken a section at B, and now if I consider the right hand side and balance just the free body balance, consider the free body of the right hand side. So at this section B, the reactions have to be W and WA. Now the same reactions on the left side would be in a reverse way, okay, because of internal forces appears in pairs and they are in opposite direction. They act as action and reaction. So this now becomes a cantilever with the load W and a moment WA. Now we have to remember two derivations. Like when you have a cantilever beam and a load P is applied, the vertical deflection delta is nothing but PL cube by 3I. Now this is derivation from standard case which you would have derived by double integration method. And also when you have a moment, let's say clockwise, the end deflection, let's say delta, and that delta is nothing but ML square by 3EI. Okay, ML square by 3EI. So now because of this W there is a vertical deflection delta, and because of M, because M is anti-clockwise and that will bend, so because of W the deflection is like this, and because of M the deflection of the beam will be like this, so it will be something like this. So when you combine these two cases, this delta and this delta, if they are equal, the deflection at B may become 0, and that is what is this case. So deflection due to, because M is anti-clockwise, so because of W, let's say delta 1, and because of M2 delta 2, and there has to be 0. So PL cube, so WL cube by 3EI, because of M, which is M is WA, ML square by 2EI. Sorry, this I have written wrong. So this is ML square. This delta due to M is ML square by 2EI. Okay. So these are the two standard cases which you got to remember these formulas. Otherwise you need to derive, but I'm afraid how much time will be there. So you got to remember these things. Okay. So it is equal to 0. And WEI will cancel, L square also will cancel, so L by 3 minus A by 2 is 0. So L by A is asked, and that is nothing but 3 by 2. So the answer is 3 by 2. The answer is A. So this is a simple problem. Only thing is you need to first get the loading at B, and then based on what is acting you have to apply. So these are just two cases, and A and B you have a P applied and you have a M applied. So because of bending moment what is the thing, and because of load what is the thing. So these two you have to combine in a proper way depending on the direction of the load. So this is a good problem, 3 by 2. Thank you.